All right, looking at number 30 here. Plots of land between two roads are laid out according to the boundaries shown. The boundaries between the two roads are parallel. What is the length of plot 3 along Cheshire Road? So again, we've got these parallel lines here. That's what these little triangles mean. And if we have parallel lines, we're going to use the corollary to the side splitter theorem that says that if we have three parallel lines that intersect two transversals, in this case, our two transversals are Cheshire Road and Shelby Road, then the segments intercepted on those transversals are proportional. So I'm going to go ahead and set up my proportions here. The length between plot 1, I think there's supposed to be a line here, between plot 1 and plot 2 on Cheshire Road is 60, so I'm going to have 60 over the piece that we don't know, which would be this length of plot 3 on that same side, so 60 divided by x equals, on my other side here we've got 36 and 48. Now it's just a quick cross multiply here. Go ahead and pause this video, try it out yourself, and then unpause it when you want to check your answer. All right, we should have ended up with 80 yards. I do just want to point out really quick that if you would have set it up like this, 60 over 36 equals x over 48, when you cross multiply, you're still going to get the same thing. So even if you set it up wrong, you will most likely still get it correct, as long as you are setting up the proportions correctly. All right, number 31. I have that AB bisects angle CAD, so that means that these two angles here are congruent. The length of AD is 16, CA is 5, and CB is 10. What is the value of x? So this is going to be using our angle bisector theorem. When this is being bisected, that means that it's dividing the opposite side into two segments that are proportional. So I'm going to go ahead and have a proportion here with 10 over x is going to be equal to, now since I started with this side here of 10, I have to use that same side of the triangle, so 5 is going to go on top, and 16 corresponds on that side with x, so that's going to go on bottom. And then we just cross multiply here and solve. So we end up with x equaling 32. All right, let's go ahead and look at proof number 32. We know that AE is parallel to BD. We know that AE is perpendicular to EB, and that BD is perpendicular to DC. We're trying to prove that these two triangles are similar. Well, we already have two right angles, and we already know that those are going to be congruent, right, since they're both right angles. So we don't know anything about a side, so I'm guessing the other thing that's probably going to be pretty useful here is to know that another angle is congruent. Now, we cannot say that this angle here and this angle here are congruent by vertical angles. That is not something that we can say. But we can use this idea of parallel lines cut by a transversal. Now, if I look at that drawn with those highlighters, if my parallel lines extend, that red line is my transversal, I can go ahead and say that this angle right here, angle EAB, is going to be congruent to angle DBC. Okay, and then I've got two angles that are congruent to another two angles in another triangle, so I know that those are going to be congruent. So let's go ahead and write out this proof here. My first statement is always going to be my given. You can feel free to write all that out. I just want to do a little quicker. So next thing I know is that, and again, the order on this doesn't super matter. I can go ahead and say either that angle EAB is congruent to DBC first, or that my right angles are congruent. But first I need to say that they are right angles. So let's go ahead and say that angle AEB and angle BDC are right angles. And that's by your definition of perpendicular. Okay, now that I know that those are right angles, I can go ahead and say that they are congruent because all right angles are congruent. Now, the order of these two steps do matter. I have to say step number 2 before I say step number 3. However, this next step that we're going to do could have gone before step 2, and that would be okay. Okay, so step number 4, I need to go ahead and say that this angle up top is congruent to this angle down below. So we'll say angle EAB is congruent to angle DBC. I can't just say angle A and angle B because there's other angles that correlate to angle B. Okay, and then we can go ahead and say the reason that these are congruent is because they are corresponding angles from my pair of parallel lines. Okay, and then now that we know we have two angles that are congruent, my last step is to say that triangle AEB is similar to triangle BDC by angle-angle similarity.